All right, so in this video, we're going to go through sample question 105 from the Society of Actuaries ExamP list of sample questions. The question reads, let x and y be continuous random variables with the following joint density function. We need to calculate the covariance of x and y. All right, so what do we need to know? Overall, this is a fairly simple problem, very standard. You should be familiar with the following formula. The covariance of x comma y is equal to the expected value of xy minus the expected value of x times the expected value of y. So we're actually going to need to know what the expected value of xy, expected value of x, and expected value of y are, and let's just go about calculating this. Right? So let's start with calculating the expected value of x. Make sure I'm in frame there. Yep. So the expected value of x should be equal to, integrating, right? What am I integrating? It's the thing inside the expected value with the density function. X multiplied by 8 over 3 xy is going to be 8 over 3 x squared y. And in this case, I'm going to need to do dy dx. Because what are our limits of integration? What are our bounds? That's going to be defined right here, right? X goes from 0 to 1. Y goes from x to 2x, all right? Now, when you're integrating, it's important to know that these limits of integration are allowed to contain the variable that are on sort of like the outer parts of the integration. Like this inner integral right now is allowed to contain x. This outer one is not allowed to contain y, which is why I need to write this in a specific way, because the limits of integration here are x to 2x, and the limits here are 0 to 1. Okay? So now let's integrate. We are integrating with respect to y, and this is simply going to become integral from 0 to 1 of 4 over 3 x squared y squared, evaluating from x to 2x, and dx, right? That's still there. And that is now equal to 4 over 3. Just make sure I have this right. Yeah, so I'll just rewrite this. 8 over 3. Oh, no. Sorry about that. Okay, so y squared, 2x squared, 4x squared should be 16 over 3 x to the 4th. And then this simply becomes minus 4 over 3 x to the 4th, which gets us integrating 0 to 1, 12 over 3, which is simply just 4 x to the 4th. Great. Now, integrating this shouldn't be too difficult. This is going to be 4 over 5 x to the 5th from 0 to 1, which, obviously is 4 over 5. Great, so we found one of our components. Let's try and find the next one. This is going to be, at this point, largely a calculus problem, right? The probability theory part of this was done in just this one step, right? Kind of like how I always say to calc students, the hardest part of calculus is the algebra. I think one of the harder parts of probability theory is the calculus, right? Because we're already done with this part. Now it's just actually computing this. Now 0 to 1, x to 2x of 8 over 3 xy squared dy dx. Okay, this becomes integral from 0 to 1, 8 over 9 xy to the third, x to 2x, 0 to 1, make sure I have this right. This becomes 8x to the third, so 64 over 9. Right, 64 over 9 x to the fourth minus 8 over 9 x to the fourth. And just so I don't make an embarrassing mathematical error, 64 minus 8, 56 over 9. So we have 0 to 1, 56 over 9x to the fourth dx. And that is equal to 56 over 9 x to the 6, which is equal to 56 over 45 x to the fifth evaluated from 0 to 1, which is 56 over 45. Okay, so now you have e of y, and finally we're going for the expected value of xy. And that's going to be, once again, we're integrating 0 to 1, x to 2x, and this time we're doing 8 over 3 x squared y squared dy dx. So integrating y first, we get 0 to 1, 8 over 9 x squared y to the third x to 2x. That's going to be 0 to 1, 64 over 9 x to the fifth. Right, just making sure there. That's 8, right? That's, yep, x to the fifth. Minus 8 over 9 x to the fifth, which gets me integral 0 to 1, 56 over 9 x to the fifth. Oh, dx, of course, can't forget that. And this gets me 56 over 54 x to the sixth from 0 to 1, which is 56 over 54. Okay, so all of this calculus just to do this and plug in our information. All right, so e of xy is equal to 56 over 54 minus e of x, which was 4 over 5, multiplied to the expected value of y, and that's 56 over 45. Now let's plug this into the good old TI-30X, and we should get the right answer. Yeah, the secret to passing these exams is actually, and this is a little known fact, so you heard it from me first, is to always get the right answer. That was a stupid joke. I'm so sorry. It's equal to 28 over 675, which is approximately, rounding to 2 decimal places like the answer choices have, 0.04. Answer choice A. All right. So overall, not a tricky problem, just like computationally annoying, right? Nothing was difficult. The only things you needed to know in terms of like the probability thing, know this formula for covariance. Covariance of x and y is equal to the expected value of xy minus expected value of x times expected value of y. Okay, know that. And obviously know how to do an expected value, right? When you have a continuous distribution and you're given the density function, the expected value is going to be integrating over, the entire region, right? That's how you get your limits of integration, your bounds of integration. And the thing inside the integral is going to be the density function multiplied by what's inside the expected value. And after that, Calc 1 class, right? These were actually very nice, decently easy integrals, like nothing weird about them. So that pretty much covers it. If you have any questions, throw it down in the comments below. I'll answer to the best of my abilities. If this video helped you out, hit the like button, subscribe. That very much helps me out. And if you want to see more questions like this, more videos like this, I have a playlist. Check it out. But other than that, thank you for watching. Hope this helps.